Hello and welcome to the introduction video of the maintenance cleaning for Toray MBR. Maintenance cleaning is a method to keep the MBR running consistently. Let's begin. The conventional product, known as the TMR module, had a structure where PVDF membranes were attached to both sides of a support plate. Currently, Toray have developed and launched the new module called the NHP module. One of the characteristics of the NHP is the thickness. NHP is thinner than TMR, going from 7 mm to 2 mm. Toray has reduced the thickness of the element, dramatically improving the membrane area per single area. The NHP element is a membrane element without a support plate. It consists of 50 elements bundled together to form a cassette. The module is completed by loading these cassettes into a frame. The key feature of NHP is that it increases the membrane surface area by 1.5 times in the same volume. Additionally, by omitting the support plate, the module is lighter, and the membrane can be replaced in cassette units, greatly improving maintenance. In MBR, activated sludge is filtrated by membrane to obtain filtrate water with controlling sludge accumulation by air scouring from the bottom. TMP usually increases with accumulation of fouling, and when it reaches the specified operation criteria, recovery cleaning is required to decrease TMP. This graph shows the image of TMP behavior. Changes in water quality or temperature can deteriorate the properties of sludge, causing a sludge accumulation on the membrane surface, which may result in a rapid increase in TMP. Since this phenomenon occurs suddenly, it is quite difficult to predict and deal with environmental changes. MC is an operating technique that implements chemical cleaning more frequently and regularly. These figures shows image of RC and MC. In case of RC, even though the operation is stable, TMP may suddenly increase. In case of MC, it is characterized by implementing chemical cleaning within the stable area. In this way, membrane can be kept in preferable condition. This table shows the difference between RC and MC. Although MC requires cleaning more frequently than RC, the concentration of MC is much lower than that of RC. While this technique is common for hollow fiber membranes, it hasn't been used for flat membranes. This reason will be explained next. This table shows chemical volume and chemical injection speed of each TMR and NHP. These schematics show the cross-section images of chemical penetrations. TMR sheet is fixed to the support plate only at the end, so the membrane swells during chemical injection, requiring more chemicals to penetrate, which also takes time. On the other hand, NHP sheet doesn't swell because the NHP element is bonded with dotted adhesive resin across the entire membrane surface. Therefore, a small amount of chemicals can be used for cleaning, reducing the amount of chemicals by approximately 65% compared to TMR. Furthermore, due to the smaller volume of injected chemical, NHP offers the advantage of requiring only 1/3 the injection time compared to TMR. The operational performance test of NHP with MC was carried out at a sewage treatment plant using double-deck membrane module NHP 210-600D. The schematic flow and operation conditions are shown on the left side, and the operation results are shown on the right side, representing the days of operation and TMP. During the first period without MC, the operation was unstable due to fluctuation in the inlet sewage quality, and the activated sludge was deteriorated, resulting in the need for high-frequency RC. On the other hand, second period with MC, despite same inlet sewage, stable operation was successfully achieved for approximately 100 days. Another operational performance test was conducted at an industrial wastewater plant. The schematic flow and operating conditions of the MBR plant are shown on the left side, and the operating results are shown on the right side. Using a double-deck module, the upper module was operated without MC, and the lower module with MC. The flux in the lower module was set higher than in the upper module. As a result, the lower module with MC could keep TMP the same or lower than the upper module without MC at all times. This result indicates that MC allows to operate flux higher in difficult-to-treat wastewater plants, which have traditionally been difficult to operate with only low flux. This figure shows case study of operation cost with the treatment capacity of 5,000 cubic meters per day. NHP requires a small amount of chemical and MC consumes quite a less chemical consumption than RC. Therefore, operation cost with MC are equal to or lower than without MC. With this, we have finished introduction of the maintenance cleaning. Thank you very much for your attention. If you have any questions, please don't hesitate to contact us.